Questions 11 through 20 on the 2002 Grade 11 Fermat Math Contest. A line passing through point 0, -2, 1, 0 also passes through the point 7b. The numerical value of b is. So all lines have the form y equals mx plus b. M is the slope and b is the y-intercept. So they've given us 2 points, so let's plug them in. The first one is -2 m times 0 plus b. So this means that b is -2. So let's use that. Y equals mx minus 2 is our equation. Now let's plug in the next one. 1, 0, 0, 1 minus 2 like that. And therefore m is equal to 2. So our equation is y is equal to 2x minus 2. And now they want you to find b, since this is a point on the line. So the x coordinate is 7 and the y coordinate is b. So we've got 14 minus 2 is b, and therefore b is equal to 12. So 11, the answer is A. How many 3-digit positive integers are perfect squares? Perfect squares. So the key is that they're 3-digit numbers. So when I make perfect squares, 2 squared, 3 squared, all that, initially all of those perfect squares are not going to be 3-digit, right? Because 3 squared is 9, 4 squared is 16. This is obviously a 1-digit number, 2-digit. So I want to get up to my 3-digit numbers. And how do I do that? Well, 9 squared is 81, but when you get to 10 squared, you get a 3-digit number. So I'm interested in these ones, not the ones up here, but the ones that are going to happen here. And similarly, eventually we'll get to a 4-digit, and those ones I won't want. So if you do this in your head or on a calculator, you'll figure out that 31 squared gets you the largest 3-digit number, because 32 squared is 1024. That's a 4-digit number. So we only want these ones. So how many are there? How many of these were there? Well, 10 squared, 11 squared, 12 squared, like that, all the way up to 31 squared. So you can easily count that. It's basically 31 minus 9, which is 22. And that would mean 12 is B. A double single number is a 3-digit number made up of 2 identical digits followed by a different digit. For example, 553 is a double single number. How many double single numbers are there between 100 and 1000? So what I'm going to do is look at it in categories. The first category being from 100 to 199, and then from 200 to 299, and so on. The 300s, the 400s, right? In categories like that. All the way up till the 900s. So for the first category, what is a possible double single? Well, any number in this category has to start with 1, right? Because it's between 100 and 199. And therefore, the second digit has to be a 1. That's the only way you can get a double single. And what about the third digit? What can it be? Well, it can be anything except 1. Because if you make it 1, that's not a double single, that's a triple. So it can be a 0. It can be 2, 3, and so on, right? 4, 5, 6. All of these qualify as double singles, this phrase that they've created. So I just listed them all. How many did I list? 1, 2, 3, 4, 5, 6, 7, 8, 9. So in this category, I got 9. How about the next category, 200 to 299? The first digit is going to be a 2 for any number in this category, the next digit has to be a 2 in order for it to meet the criteria for a double single, and the last digit can be any number except 2, because if it's a 2, it's not a double single, it is a triple. So 220, 221, 223, 224, and so on. Very similar to previous. And finally, let's count how many. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 again. So each of these will produce 9. This category, 9, 9, 9, 9, 9, and 9, and 9. So you had them all listed out. Let's add them. So we got 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 nines, which is 9 times 9, and therefore 81 is the total number of double singles. And that would mean 13 is A. The natural numbers from 1 to 2100 are entered sequentially in 7 columns, with the first 3 rows as shown. The number 2002 occurs in column M and row N. The value of M plus N is. Okay, so first please look at column 7, right here. You'll notice in row 1 of column 7, the number is 7. And then in row 2, the number is 14. And then in row 3, the number is 21. So obviously, it's going up by 7. In row 4, that will be a 28. So any number that is a multiple of 7 will appear in column 7. Okay, so let's take our number 2002 and figure out, is it a multiple of 7? And it is. It's 286. So 2002 will be in this column, column 7. So I'll just put it here, 2002. So column 7, so therefore, since M represents the column, we know M is 7. Now we have to figure out which row is it in, right? All the rows are here. What row is it in? Is it in row 5, row 6, right? You get the point. Well, how do I figure that out? 7 is equal to 7 times 1. And that means it's in row 1. 14 is 7 times 2, row 2. 21 is 7 times 3, row 3. And 28, 7 times 4, row 4. You get the idea here. So we have to figure out 2002 is 7 times what? Well, you already know the answer right here. It's 7 times 286. So the row, if I can match it up here, is the 286th row. So row N, so N is equal to 286. And they want you to find M plus N. So M plus N is 7 plus 286, which is 293. So that would mean 14 is D. In a sequence of positive numbers, each term after the first 2 terms is the sum of all of the previous terms. If the first term is A, the second term is 2, the 6th term is 56, then the value of A is. So they're going up to the 6th term. So there you go, 6 terms. And put commas in there. So the first term is A, second term is 2. And then now, according to their criteria, after the first 2 terms, each term is the sum of all previous terms. So this term, which is the third term, will be A plus 2, correct? The sum of all previous terms. Now we get to this term, the fourth term. So this is the third, this is the fourth. The fourth term will be the sum of all previous terms. So we got A plus 2 plus A plus 2. The fifth term, the sum of all previous terms. So A plus 2 plus a plus 2 plus a plus 2 plus a plus 2, right? And let's simplify this instead of writing this all out again and again. This looks like 4a plus 8, like that. And let's simplify this one also. 2a plus 4. Okay? And then finally we've got our sixth term. It's the sum of all previous terms. So a plus 2 plus a plus 2 plus 2a plus 4 plus 4a plus 8. So this is 1, 2, 3, 4, 8a, and then 1, 2, 3, 4, 8, and 8, 16. 8a plus 16. And they tell you that the sixth term is 56. So this is equal to 56. 8a plus 16 is equal to 56, and therefore 8a is equal to 40, and a is 40 divided by 8, which is 5. So number 15, the answer is E. If AC plus AD plus BC plus BD is 68 and C plus D is 4, what is the value of A plus B plus C plus D? So we've got AC plus AD plus BC plus BD is equal to 68. Now we can factor something, factor out an A. That would give you C plus D. Factor out a B, and that would give you C plus D equals 68. And C plus D, they gave you a value for. So plug that in. No reason to go any more complicated than that. There you go. And this becomes 4A plus 4B is equal to 68. Factor out of 4, A plus B is equal to 68. And then A plus B would be 68 divided by 4, which is 17. And now let's turn our attention to what they want. They want us to figure out A plus B plus C plus D. Well, A plus B we just figured out was 17. And C plus D they give us in the question. It's 4. So 17 plus 4 is 21. So number 16, the answer is D. The average age of a group of 140 people is 24. If the average age of the males in the group is 21 and the average age of the females is 28, how many females are in the group? So I will denote X and Y as the total number of people, the sum, and that is 40. They tell you that there's 40 people. And X can be the males, and Y can be the females. Probably makes sense to make X the females, since only men have Y chromosomes, but that's completely unrelated. So here we go. If the average age of the males is 21, then their total age would be 21X. And very similarly, if the average age of females is 28, their total age would be 28Y. And we want to create an average, or get an average. So you divide by the total number, and the total number is 140. And they give you the average. It's 24. They give you that right there. So now this is basically two equations, two variables you can solve. Before I proceed with this guy, I'm going to isolate for one variable. And the variable that I'm going to isolate for is females, right? We want to figure out Y. So I have to get X in terms of Y. So that means X is equal to 140 minus Y, like that. And substitute that in. So 21, 140 minus Y plus 28Y is equal to, cross multiply 24 times 140, like that. So now you just multiply this out. You get 2940 minus 21Y plus 28Y is equal to 3360. And then minus 21 plus 28, that's 7Y. And then 3360 minus 2940 is 420. And therefore y is equal to 420 divided by 7, which is 60. So since y represented the females, there are 60 females in the group. So 17 is D. A rectangular piece of paper, AECD, has dimensions 8 by 11. Corner E is folded onto F, which lies on DC. As shown, the perimeter of trapezoid ABCD is closest to. So if you were to blow this up, give us a little bit more space to work with here, I want you to notice something. When you flip this, when you fold it, when folded, EC will land where? Where does it land? Lands on what? It lands on FC. This guy, when you fold it over, it will come and land right there and match exactly the way they show you in the diagram. So that means that EC, the length, is the same as FC. Now EC, we know the length. It's 8 because this is a rectangle. So EC is 8 and therefore FC is 8. If FC is 8 and this whole DC length is 11, that means DF is 3 and therefore AB is 3. So we've got almost everything. We just need BC and then we'll be ready to calculate the perimeter. We can do that by Pythagoras since that is 8. So BC squared is equal to 8 squared plus 8 squared. So that's 64 plus 64, and that will be the root of 128, and that is approximately 11.3. So I'll put 11.3 there. And now what do they want? They want the perimeter of trapezoid ABCD. So ABCD back to 8. The perimeter. 3 plus 11.3 plus 11 plus 8. Correct? And that totals 33.3. 33.3 is our answer, and therefore 18 is A. If 2 to the power of A times 3 to the power of B is equal to 8 times 6 to the power of 10 with A and B as integers, B minus A is equal to. So we have 2 to the power of A, 3 times 3 to the power of B is equal to 8 times 6 to the power of 10, like that. So let's concentrate on the right side. So 8 I'm going to write as 2 to the power of 3, and the 6 I'm going to break up into 2 times 3 like that. Because we've got to get everything in terms of 2's and 3's to match them. Now, this guy will break up into 2 to the power of 10 and 3 to the power of 10 like that. And of course you're multiplying. And then since the bases are the same, you add the exponents. So 2, 3 plus 10 like that, times 3 to the power of 10. And this is 2 to the power of 13 times 3 to the power of 10. 2 to the power of A, 3 to the power of B. So A is 13 and B is 10. So they want B minus A. So B minus A is 10 minus 13, which is negative 3. And therefore 19, the answer is E. In the diagram, YQZC is a rectangle with YC equal to 8 and CZ equal to 15. Equilateral triangles ABC and PQR, each with side length 9, are positioned as shown with R and B on sides YQ and CZ, respectively. The length of AP. Okay. So let's label this in a way that it doesn't make it too confusing. The first thing I want to label is the fact that these equilateral triangles have side length 9. So this is 9, that's 9, and this base is 9 right here. And very similarly, that's 9, 9, and 9. All right? Like that. Now, I want to label a few other things that will help us figure out the distance from P to A. And the first thing I'm going to do is draw a line from P to A to illustrate what is it exactly they want to figure out. P to A is like that. It's a strange type of distance, but that's okay. I think we can figure this out. And then I'm so used to Pythagorean theorem that I'm going to try to make a Pythagorean triangle out of this. And let's see if I can do that. I will drop a perpendicular from P down till about here. And I'm going to join A to that base like that and make that a right triangle like this. Okay? And let's see what we can get. Now, a few things that I noticed immediately is that if you were to drop that perpendicular, you cut RQ in half basically, because this is an equilateral triangle. So that means this is going to be 4.5 like that. Okay? And therefore, we need to concentrate on figuring out this length here and that length right there. Now, this length is another length I need to figure out. I'll draw the diagram first. From A all the way down like that. Okay? And that's identical to this part right here. From P to that RQ. Why? Because they're exactly the same in terms of their dimensions, those triangles. So let's do that first. We've got, I'll just call it H for height. And we know that from here to here is 4.5. Right? 9 represents, of course, the entire base C to B, so don't get confused. 4.5 is just the half of that because that H will cut CB in half. So let's use Pythagoras now on this triangle right here. So we've got 4.5 squared plus H squared is equal to 9 squared. Okay? So H squared is equal to 81 minus 20.25, and therefore H squared looks like the square root of 60.75, like that. And that is making H approximately 7.79, like that. So H is 7.79. Okay? So think about it. If H is 7.79 and H goes basically up till here, that means this distance right here in red, right there, that's got to be 8 minus 7.79. Correct? Because the whole thing is 8, and from here to here is 7.79, so that little guy is 8 minus 7.79. And that is equal to 0.21. Okay? So that means that this little guy here is 0.21. So I'll just put that in there, 0.21. And this, from P down to the base, is H. And if we figured out H already, it's 7.79. We don't have to do it again because these two triangles are identical in terms of their length. So I think we've got the full length from P down to the bottom of this triangle. It's 7.79 plus 0.21, which is 8. All right? So I hope you're convinced so far, and I hope the diagram is not too confusing. One final line, and then I will be complete with this diagram. Won't have to make any more messiness. I'm going to draw a line from B all the way to the top. So like this. So not really all the way to the top, but just till that red line. And now I'm going to label something that I hope you can see. The whole distance from C all the way to Z is 15, correct? But we know that the distance from C to B is 9. And I even labeled that there. So that means that B to Z is 15 minus 9, which is 6. Okay? So that's part of our puzzle here. And then you remember this was 4.5, so therefore that's 4.5 right there. Another 4.5 in there. So that means this is 4.5. 4.5. And now there's only one distance remaining, and I'll call that an orange. Right here, that guy right there, if you can see what I just drew there. That little guy in there. If we can get that, we're set. Well, we can, because from here to here is 6, correct? And from here to here is 4.5. So that distance here must be 6 minus 4.5. And therefore that's 1.5. So I think I can squeeze that in, 1.5. And there we go, we're done. We have it all. I will draw that triangle again here to avoid creating any more messiness. Right, something like that. And now let's label the sides. This is P and this is A. This whole side is 4.5 plus 1.5, so that is 6. This side here is 8. We got that right there. And therefore now we can find AP through Pythagoras. AP squared is equal to 8 squared plus 6 squared, 64 plus 36, which is 100, and therefore AP is equal to 10. Number 20, the answer is A.